afraid of this thing. Is it okay? Okay, good morning. I'm a chemist, to answer Ivo Hammer's question before it's asked. I'm a PhD chemist, and the angle I have on color, or on identification and translation of color, is going to be a little bit of a different one. There. This is a little bit of plaster from a barragan. Alto would know which building it is, from Mexico. And if you look at it, you see that it's a three-dimensional information structure. For me, the material question doesn't end when you look at the plaster. It includes the color as well. And our approach to color is that color itself is also a material. The question that I'm going to try to answer is one possible way that we can gather information and restore the materials also in a polychromy. Lena spoke yesterday about the fact that color 1920, when you look at it under the light microscope, always looks like a rainbow. It's a wealth of color that you see in these color samples. The plaster color card was in the archives of the Fondation Le Corbusier. And every single sample, if you look at it under the microscope, shows this incredible richness of many, many different colors. And the question is, how do we get the information from this sculpture, and what can we do to restore or to make it visible, at least to understand the way color was used in the 1920s? Isn't in our topic. By way of an introduction, I start with Maison Blanche, which was restored in 2006, I think. And it was a low-budget affair. It's always, when we go on site with these things, usually we don't have the resources you spoke about this morning, and the time is always of the essence, and often it's not possible to remove all of the plastic layering you would like to remove to get a new, to really restore or to go back to the original breathing building materials. And here, one big experience we had was the white of the exterior. It had, it was originally a lime white, of course, made with a yellow stone that's common in that part of Switzerland, the Haute-Rive stone. And we were asked to produce a new lime paint to put on top of the old one. The one that was underneath that also couldn't be removed was from Saks, and it was made with titanium white. And then when we made just a plain lime paint without titanium, and casein paint with lime in it, then it looked terribly yellow compared to what was underneath. It looked terrible. And they called me on the telephone. All of the experts were together when the paint work was initially done, and they called and they said, Madame Trautwein, you have to come on site immediately. The house isn't going to be a Maison Blanche anymore, it's going to be a Maison Jaune. And we went there, and then I did some more research, and it turns out, of course, that this is not a surprise to you, that the concept, I don't like this thing, that the concept of white has changed considerably in the last 100 or we're talking about 80 or 90 years here. And white is a philosophical concept. It's a place to hide for much of architecture. It's a myth. And of course, it's also a material. Yes, you can tell here. This is the white that was found, or a sample of a white paint found again in the Le Corbusier archive. And titanium white has a completely different structure under the microscope. I think what many people don't know also is that paint pigments today are usually developed to hide well. Paint work isn't allowed to cost anything today. The painter has to apply paint for €5 per square meter if it's white, including the material. And so the titanium white used today is usually micronized, which means that all of the crystal structure in the pigment is removed, and you get a white that is quite white, and it has no reflectance, no crystals in it anymore, so you have no light reflectance. And this was, of course, quite different in 1912, 1920, up until the Second World War. And the question that we started asking was how can you get back to different color concepts, and also why is it so often done wrong? If I look at the Meisterhäuser Klee Kandinsky or the Bauhaus in Dessau, it's much too white. There's titanium white, I think, on the surface. You could know, but it seems to me that it's a much too white, perhaps not. We'll speak about it later, or you can correct me later, please. But what's usually done in restoration when I'm involved is that some kind of sampling is done by people that do very good work, and then it's translated to a reference hue. Common is to use the NCS color communication system to define the references. There are others in the United States. Mansell is common. But what happens is that a material is translated to a hue, to a standard of color perception in this case. And that's translated again to a CEI, colorimetric value, which is then translated to a formulation, which is then translated to a paint, which is put which is used in the intervention. And you have all these changes and translations which happen in the background, and no one really knows what happens in the process. And so this is something I think that very often leads to somewhat surprising results. This is another sample from Maison Blanche. And in Maison Blanche, very good work was done with very limited resources. But we didn't have, for instance, the light microscope that we're going to be using further, that we used in the Villa La Roche. And you wound up going to scratched samples which are somewhat damaged on the surface, and you use some kind of color reference charts, which are tiny little samples that you put next to the window. And something is done. Someone makes the best choice. Someone in the hierarchy is at the top of the deciding angle or end of things, and he or she decides to do something and it's done. But here you can see, I think if we had to do it again, we would use a much more ochre-based paint, or one with more umber in it. We would have to look at it in detail. Here, a different approach was used. I actually left Maison Blanche thinking it would be very nice to have a more accurate method of assessment and identification. And my company went and bought a very good light microscope, which is digitalized, so we can get quite a bit of information from very, very small samples. Villa La Roche was restored 2008, 2009, and it was a phenomenal work in terms of the communication between all of the different people involved. The restorators and the architects and the foundation themselves and the culture, people from the Ministry of Culture in France, everyone that was involved was very, very cooperative and very open to dialogue, to be able to talk about, again, with the limited resources and the constraints involved, what the best method would be to make visible how Le Corbusier worked with color in this iconic piece of architecture. I was given about 30 samples. Some of them are less than one. They're about 2 by 8 millimeters, and several surprises came out in this course of the work. For one thing, Ariel Bertrand came at some point and she said, almost all of the scratched or laid open windows I have, they all have red under them. I think the whole building was red at one point. And we found out, it seems likely, it's the most likely explanation, that Le Corbusier had pigment put in the primers. He used oil primers to fix the plaster, or to fishing, the plaster, and the building, the rooms that later became ochre or red ochre had burnt sienna pigment in them. You can see it here in the lowest layer. And then experiments were done with the color. Often the first coat of paint was a little bit different in color than the second coat of paint. So the painter went around and did the first coating, and then it was assessed, probably the appearance of the room, is it too much or too little. Here the second coating was a bit lighter, and it's the one that we wound up restoring or reformulating. What you can see here also, if you look at the successive layers of restored paint, paint gets more and more plastified in terms of the binder and also in terms of the pigment. You have very crude, almost sand-like pigments bound, very loosely bound in the lowest layers, And then you start getting paint with lithopone white pigment in them, and you still have natural red ochre in the initial renovated layers. And then later on you wind up having colors that look more and more like Miss Piggy. They wind up being acrylic binders and just the inky kind of pigments that are used today. If you use red iron oxides today, it's like an ink, and it just holds around, it goes around. I mean, it's like a pink plastic mass, completely different from the materiality of the lowest layers, which was like a loosely bound sand. Here's this sample of the railing. The progression is opposite from the one that we just heard about in England. The railing here on the very top right corner, you can see the iron. And the initial coating was a very, very dark green-gray, made with cobalt green and noir ivoire with a charred bone black that Le Corbusier used. And each successive layer of paint gets a bit lighter and a bit more like the garden green or the green alkyd oils that became popular in the 1950s and 1960s. And here again, it was possible to go back to a paint reformulated, just like the original one. We used a bone black and cobalt green and linseed oil paint, and it looks quite different from what it was like before. There was a fortunate fact that one radiator in Villa-la-Roche was never repainted. All the other radiators were repainted, one of them was not. And when we looked at it initially, we thought it was painted in a dark umber. It looked like a very, very warm gray-brown. And then under the microscope, we did some microchemical analysis, and it turns out that the brown was just mingled in rust. And so we started doing this kind of procedure. What you see, the shiny thing is the pincette, the pinchers, whatever it's called in English. And then between the two, this is under the light microscope, we have a lower layer that's a reference color, a lime paint or a glue paint from our company where we were testing color, and then a very small bit of the radiator paint, and you see an almost intact paint surface, which was the original paint, since we know that this thing was never repainted. And the paint that's visible on top is a mixture of paint with rust. I presume that the lower, the intermediate paint layer, which is the one that was, again, restored in the color, had much more lead in it, so it seems to have been less affected, or for some reason it wasn't damaged here. Many of the other pieces we always compared photographs, of course, many others just showed the mingled brown mess paint. But here we were able to find an intact sample, and we were able to go back to a gray that was very close in structure and in pigment and also in the binder to the original. Here, this is a piece from the gallery, from the wall behind the famous red ramp. And you see again that the primer had some black pigment in it. So it seems here that experiments with color even started at the primer level. And the layer that was restored was this one here. And if you have a better photograph, this one isn't very sharp. It's just sharp in the top. You see that the paint structure winds up being the same with what was renovated and what was originally used. Oh, I just see. For us, we wound up with our standard for saying that we're going to stop reformulating the paint. What we did is we always took a good sample under the microscope. We made a formulation of the paint in our lab, and then we photographed them next to each other. And the point, and then if it was no good, which it usually wasn't, we probably made 300, 400 different formulations to finally come down to 14 different paints. When the hue was right, this is the only thing assessed by our standard color systems. So the hue is one thing that had to be right, the texture had to be right, and the granular structure of the whole paint had to correspond to the original of the binder as well, of course. Here is the progression of ultramarine blue. Le Corbusier had made a list of pigments to be used in this, in the Villa La Roche, and there were 2 blue pigments in it, which is an interesting thing I'm going to come back to. But here the ultramarine blue, which is a very, very deep ultramarine going right off the gallery or the entrance where you walk in, it had shifted to a real plastic paint, and I happen to know what this is because it was made, this was the final paint that was done before we went back to the original color definitions. And it's an acrylic paint made with ultramarine pigment, so the pigment was right, but the material was completely wrong, and the hue was also completely wrong. And the way this had arisen was that Madame Tréhin, who was president of the foundation before Michel Richard, walked around with a Salupra wallpaper books, and she said, and she knew that Villa La Roche was built 1926, so she used the Salupra 1 collection, and she took the deepest ultramarine blue in the Salupra 1 collection, and then she had that paint formulated, and since she said it has to be stable, you have to be able to touch it. She ordered it in an acrylic. But it turned out, of course, through the scratching procedure and then also under the microscope, that, under the microscope we also saw that it was a much, much deeper blue, because the Salupra wallpapers were Salupra wallpapers, but they weren't the only way that Le Corbusier used pigments in his buildings. And so we went back to a much deeper ultramarine blue definition in hue, and it's much, much nicer, of course. It's completely different. What happens today usually is with these translations where you just go from a hue to a reference standard and then to a mixed paint that has God knows what in it, you usually translate to phthalocyanin blue. Phthalocyanin blue is the one blue pigment used to make all of the reference samples in the NCS and RAL design. All of the common pen decks use phthalocyanin blue to denote all of their blue color, all of the blue color shades that they have in their color language. And the structure of the pigment, of course, is completely different. Here you have just like an ink, and it just coats the paper. You have no structure in it at all. So if you change, I think if you change this kind of materials in the paints and in the pigments and in the binders in architecture, you're changing the expression of the architecture completely. You might be close in the hue, but you're not going to have the same material and you're not going to have the same spatial effect. Here is the blue that we made the lower sample is the blue that we reformulated, and that's now in the Villa La Roche, and the top is the original blue sample, another small part of it, and on the right you see where it's used. It's in this place, it's in the lower part of the building. And one thing that I also learned here was that the craftsmen that were on site in these buildings, they had a profound knowledge of pigments, pigment combinations, and pigment binder combinations. For instance, they knew in the Villa La Roche that you shouldn't use linseed oil to emulsify an ultramarine blue paint. Of course, Le Corbusier, when they built this originally, they also didn't want the paint to be so sensitive to touch that everyone who walked through would have ultramarine on their clothing. And here they use casein as the glue because it binds the pigment better and it doesn't yellow with age. And this kind of material knowledge, in the brown pigments they use linseed oil to emulsify the paint because brown pigments umber doesn't care if it gets more yellow with time. It keeps the aesthetics of the structure intact. So this kind of knowledge I find it fascinating. Unfortunately, much of it's gotten lost. Here, what I found interesting also was that for this one single, it's a few surfaces, but it's not many. Le Corbusier didn't use ultramarine pigment, he used bleu charron. Chariot's blue, it makes much more solid blue colors. It's the ultramarine light shades are very elusive. They look like the sky, or they look they don't have much solidity to them. If you make light blues with Baryte and with Prussian blue, the bleu charron, you get a little bit different shades of blue and they seem much more metallic. And I think from what we've seen now and from also the fact that in the Salupra wallpaper samples, Le Corbusier made the same page, he has the exact same alignment of colors, but with two different blue pigments. And so he differentiates his blues. And I think now that Le Corbusier, whenever he had a wall that had to support weight and that was standing in the light, he used the bleu charron. And when he was working in tight spaces or in dark spaces, and when he had architecture that didn't have to carry much weight, he used the ultramarine pigment. So he differentiated the function of the color in architecture according to the pigment, which is quite interesting. And it also gets lost in the translation, if it's all just translated back to some kind of norm hues. In fact, if you look at the Salon Rawan colors, you find that there's always this doubling of all of the deep shades. Salon Rawan wasn't just the very light shades, it also has some very full strength or high strength colors. And you have always the shady, sort of the grayed, full-strength colors, which are shown on the left, which are the ones that tended to be used in the shadows, or where the light wasn't so good. And on the right, you have the very vibrant, dynamic colors, which are the ones that have a yellow part in them, which were used when space had to be articulated differently. It's a very interesting division of pigments. I think it was common knowledge at the time. You find it cited, for instance, in Kandinsky's on the spiritual and the arts, über das Geistige in der Kunst. He writes about the blue and yellow content of colors as a specifier of whether you want the surface to advance or to recede. And I think this was just the way color was used then, and it's intimately linked to the materials that were used then. But that's just an aside. If you look in the Villa Laroche at these samples, you see profound differences in colors that have happened in 80 years. And the question is, of course, what happens? Sometimes perhaps it's an intention. You just can't stand to live in the pink room, even if Le Corbusier once had a pink room and you don't want it anymore. But often, I think it's interpretations based on incorrect assumptions. For instance, what a concept like light is. Or you think Le Corbusier always did this because of some secondary literature, and it turns out perhaps that the secondary literature was already wrong. The comparison of marred surfaces, like with a heater, to reference colors, and then restoring or reformulating the restored or the reference color often leads to errors, I think, in my experience. And then the really big problem is, of course, for me, for the work we do, is when the question of color is restricted to the question of hue. It's something that I find very, very difficult and very misleading, because color is completely immaterialized when you do this. Here's one example from Villa Laroche where that had happened. This is from in the bibliothèque in the library. The woodwork is painted with an oil paint. And we know from the pigment list that Corbusier had that he had used a very light natural sienna in the building itself. We hadn't found where it was used yet, and we didn't have a sample of this to analyze under the microscope. And then a team of people, I don't know who made the decision, but they had us make this oil paint. And it just didn't look right. If you looked at the fan deck of all of the Villa Laroche colors, it just didn't look right at all. And so I went back and asked Michel Richard, the director of the foundation, whether he could get us a sample of the oil. And we did the analysis, and it turns out that the sample the color should have been like this. And this is our reformulated paint, which we were finally happy with, and they've actually changed it again, so they've corrected it, and in my opinion, it's much more of a harmonious entity now with the rest of the colors. What happens when you reduce color to hue is that you negate the differences between these three color cultures. The top left is natural pigments. If you want to make a color wheel with natural pigments, normally you wouldn't, of course. But then this is the brightest colors you can get from natural pigments. If you use synthetic inorganic pigments and you make a color wheel with them, then you get the one that's in the middle. And if you use what's commonly used in the interior today, and what most paint manufacturers use to produce interior paints after all of the translation operations, is the one on the lower left. And you can see just by the comparison on a not very good slide again, you can see that you get quite a dramatic change of the red concept or the yellow or the green concept. There's a whole scientific problem behind it as well, which is nothing I'm going to speak about now, but I'm going to write it in my paper, because the reduction to hue, the color perception systems or color specification systems that are commonly used, they use rules for defining 3 variables or assigning each color with 3 variables that's accurate for light, but it doesn't actually make scientific sense if you use it with materials. You can't reduce a material to 3 variables and go back to and get sensible information out. So that's really the problem behind all of this. If you apply it in practice without knowing anything about the science or the philosophy of it, you always negate these differences. On the top, you have the same color made with a natural pigment. On the lower side, lower half, you have the same hue made with a synthetic iron oxide pigment. And it's going to make quite a difference in architecture whether you use the one or the other. I think the big factor is light reflectivity. I think, Mr. Hama, I think it's probably common knowledge for all of you, for us in the industry, and for people that don't know that are quite happy with their hue analyses. This factor of whether you have a crystal structure or not is a big difference. Here you can see an example from the literature. There's a group of people that analyzed Portuguese lime wash colors. I'll be less. And the Portuguese people found out that it makes a huge difference for lime, for the look and the color development of the lime, depending on whether you use the natural pigments, which are shown again on the lower side with 2 different kinds of spectroscopy, or whether you use the synthetic iron oxide pigments. So it's always nice to find that other people have found out the same thing and are working in the same direction. And so my suggestion for the kind of low-budget projects that we're called in on, if you really want to restore or at least understand what was once done before deciding how to intervene, then one possibility to avoid these very difficult translation processes, or the ones that jumble the efforts, is if you get a sample and the stratification, whatever the layering, is enough with today's amplification methods and with computer technology to get a very good idea and to get a clean sample of what needs to be restored or what was once originally at least used. And then you assemble information from all the means that are available, including verbal reports and spectroscopic analyses and chromatographic analyses. And you try to find out the most likely thing that was probably, you try to find the most likely version of the truth. And from that, we go to formulation steps. And then we formulate using the original pigments and binders, even if they're toxic. We're not talking about reconstruction here, we're talking about formulation. And then you formulate an assay under the microscope until you get it right. As many times as it's necessary. It's still an inexpensive procedure compared with many of the others that are commonly used and perhaps yield less accurate results when it comes to color. And then you can decide whether you want to translate, whether you want to change color, translate to a less toxic hue if it's something that contains lead pigments or barite or whatever, or you produce the reference paint. In the Villa Laroche, we had to add some PVAC binder because you can't have the very Mars-sensitive paints that would be reversible and actually the best choice. But it also has to be practical and it has to be affordable. But by following this, you can do that. So gathering the facts includes all kinds of information. Laying open the windows and collecting samples is common procedure. It's something that's frequently done. One thing that I'm working on, unfortunately, Birkhuis Verlag is having difficulties, but they asked me to write a book in which I collect this list compendium of pigments with the date of availability. I don't know if there's one available, but that kind of compendium would be immensely useful because then you can limit the number of choices. You know, if it was a yellow and it was done in 1911, you can figure out exactly what was even available at the time. Microchemical analysis gives a lot of information, of course. This is the Salubra wallpaper, 32030, which was actually made with bleu charon and not with ultramarine green and cobalt blue as we thought initially. And then you formulate the color and check it until you get it right. This is a green that we make with a natural green earth pigment, and it also came out of a renovation or restoration project. It takes a lot of work to get the structure and the hue right, but in the end you wind up having quite astonishing results. This is the salle à manger in the Villa La Roche with our color on the right and the layer to be restored seen right next to it. So this was again the point where we said now we've done the best that we can. And with that, I've gotten to the end of mine. Do come visit us. Since I work in industry and not in research, I'm lonely, or I do all of these things sort of in isolation, but I would truly enjoy to be in dialogue or exchange and to also make our pigment stocks. We have over 200 different pigments that we use to make these formulations. So take advantage of that because I'm very interested in the exchange. Thanks.